Yo, Chuck.
All right, guys, got another video on quicksort today. And what's first important about quicksort is you need to make a pivot function. So I released a video on that, but I'm just going to run through everything real fast here. And in case you didn't know, a pivot function will take like an unsorted array and whatever indices you designate as your pivot. So in this case, I'm going to specify this first value is my pivot. Let me make it 11 so it's a little bit easier to explain. So basically what happens is the pivot function will take 11 and then it wants to find the proper spot for 11 within this sorted array. So when I say proper spot, that means every value that is larger than 11 will be pushed to the right of 11, and then every value lesser than 11 will be pushed to the left. So in this case, all these values are less than 11, and then you have 11, and then the value that's greater is 199. Notice that the values lesser than 11 are not sorted, and if there was another value that was greater than 11, it would not be sorted. You're just concerned with the pivot function for finding where 11 should be in this array if it was sorted. So you just have the correct spot for 11. So let's make the pivot function real fast. Pivot equals, and it's going to take an array, a start, which equals 0, and then an end, which equals array.length minus 1. So your pivot is just going to be array at start. And then you're going to have a thing called a swap index, a variable called swap index, and basically I'm going to set that to 0 or start at the very beginning, but the idea of the swap index is every time you cycle through the data and a value is larger than the pivot, you're going to increment swap index, and you'll see what I mean here. Let's pass in an array, an unsorted array, so we can kind of get the gist of what's going on. Something like that. Okay, so my pivot I've chosen as array at start, and start is set to 0, so it's going to be 4. So my pivot is 4. I need to loop through this data here, excluding the pivot, and then compare it to the pivot. Say, is pivot greater than 1? Yes, it is. Then I need to do something. So I'm going to make a for loop. Let I equal start plus 1. I is less than array.length, I plus plus. And real quick, I'm going to need this. So I'm going to need to swap. I'm going to need to do a swap when my pivot is greater than one of these numbers. So I'm going to make a swap function real fast, and let's just do it right here. A swap function just takes an array, indices I, indices j, and I'm just going to swap them. It's nothing too crazy. So I'm swapping array of I with array at j. And notice I'm using a temp variable to store the initial value of array at I. Because if I just set array of j to array at I, it would be setting both values to array at j. So you need to store the initial value of array at I. That's all that is. Okay, so that's just a quick swap function. You don't have to do this, but it makes your code a lot cleaner and it's easier to follow. So now, like I said, I'm going to take my pivot of 4, and one by one, I'm going to compare it to values in my array. So I'll say if pivot is greater than array at index I want to perform a swap. But the first thing I want to do is increment my swap index. And from here, I'm going to call the swap function, and I'm going to swap array at I and then array at swap index. So notice I'm not swapping the pivot yet. I'm just swapping array at I and then the array at swap index. So that's like 90% of this function done right there, actually. But you'll notice my swap, array. Oh, I didn't put this in array. Okay, well that should have done that. Okay. So if I return the array right here, you'll notice my pivot of 4 is still not in the correct spot, although it's almost like pretty much done. All you have to do is perform one more swap right here with the array and then the start and then the swap index. And now if I'm to return the array, 4 will be in the correct position. So if I do that, whoops, return array. Okay, there we go. So 4 is in the correct position in this array. Notice that lesser items are on the left and greater items on the right. They are unsorted. There's no order to them. We're just concerned that 4 is in the proper spot. So this pivot function works, and that's awesome. But with the pivot function, you're not actually supposed to return the array. You want to return the index of wherever your pivot is. So 0, 1, 2. So I should return 2 here. Excellent. So our pivot function is good. Now we can move on to the quicksort. So I'm going to delete this array here. I'm going to make a new function called quicksort. It's going to take an array, a left, and a right. Okay? So the whole idea with quicksort is it is a sorting algorithm for unsorted data. So let's make some crazy data in here, something like that. Okay. So again, with quicksort, you're gonna use that pivot, and then you're gonna find the correct value of that initial element, and then you're gonna return it. But you're gonna want to kind of like break the array down in the left hand and a right hand side, and use recursion pretty much to make sure they get smaller and smaller until you can just return an array that's sorted, and then you're gonna like merge them together. So I'm gonna set my left to 0 and then my right to array.length -1. The reason I'm doing this is because I'm gonna do an if statement right here to basically check if I should be doing the recursion or not. So I'm gonna say if left is less than right, I'm gonna do stuff. So I'm going to make the pivot index here. I'll say pivot index equals pivot of the array, and then left, and then right. This is going to give me the pivot index for 5 initially, which we said what was like, let's see what this actually is. So where's the correct position for 5? So 1 is lesser than 5, 3 is lesser than 5, and you have like 9, and then 33, okay, and then like 11. All right, so 0, 1, 2. So pivot index is going to be 2 initially. Here's kind of like where the tricky part happens is now you need to split the array up. And the way you do that is you actually call quicksort again with the array and the left value, which is still 0. And then now you're going to do pivot index -1 here. And this is for your left-hand side of the array. So if our pivot index was 2 initially, this is going to be from 0 to 1, okay? And then quicksort again, this is going to be for the right-hand side. You're going to say pivot index +1. Notice by using pivot index -1 and +1, I'm avoiding the value that's not the pivot index. And then I'm going to say right, okay. Right, just like that, and then you would return the array. This is going to run recursively, and it's going to sort all this data here. So I'll enter the code, and look at that, it sorted it. So I think the confusing part is this recursion. You're calling the quicksort again, but it's kind of like analogous to like slicing an array from basically from the left to the pivot index -1. So you're just not including the pivot index. And then here you're starting at pivot index +1 to the right. So it kind of feels like you're using slice almost, like in the merge sort video I posted earlier. So that's kind of how I remember it. And then the reason you're using this left and right and you're setting them to values here is merely so you can use this if statement so you can tell how long to run this recursion for, to make these recursion calls for. So that's kind of like why you're setting these values here. And then you're just returning an array, and those will return those sorted values and cluster them together. So I hope you guys enjoyed this video. Quicksort is definitely not something easily to conceptually understand, but I hope I was able to clear some of that up and maybe just show you how to have a working copy of the algorithm. So I'll see you in the next one.